So today we are looking at this tutorial sheet. So we'll go question by question until where we feel like we can end. So I think we did question 1A here. I'm not so sure which other questions we did. Yeah, so question 1A, A, B, C. I think those are a bit light. So let's start with question 1D. Then we'll do E. Then we'll do I. So do 3 there, and then we move to question 2. So 1D. Okay, so we're doing sheet 3. We're starting with 1D, which is the integral, the root of e minus 1, running from 0. And we have 2x, ln of x squared plus 1 over x squared plus 1 dx. So we are supposed to integrate this, and if you look at this question, it's not so clear whether the derivative of x squared plus 1 is 2x, or whether that x squared plus 1, which is not in ln, is one whose derivative is that. Okay, so to avoid all those, what we do is we let u be the whole ln with what is inside, and then quickly differentiate it. So when we differentiate it, we are going to have 2x, and then we divide by x squared plus 1 dx. That's the normal way of differentiating the ln function. You differentiate what is inside it and then divide by everything. And then secondly, we are moving from the variable x to the variable u. So we can choose whether to integrate and then come back to substitute the u, or since we have limits, we can also opt to change the limits. That is, if we want. So if I want, I can say, okay, since I've changed from x to u and from dx to du, I may also substitute the limits. So I say in u, what could be u when x is the root of e minus 1 so there we're going to get ln, and because of the square, we now have e minus 1 plus 1, which is ln e, which is equal to 1. And then what happens to u when x is 0? We'll have ln 1, which is equal to 0. So that means that we have moved, when I put my integral now, I'm running from 0 to 1, okay? And then I have 2x u over, we said u to be that, so now over, can I put the x squared plus 1 here? And then I come back here, I'm looking for dx. So it means that my dx is going to be du multiplied by x squared plus 1 over 2x. So this here, when we cross multiply and then divide by 2x. So we put it where there's dx. So we have du x squared plus 1 over 2x. So this piece and that piece cancels. this one and that one cancels. So what do we get? We get from 0 to 1 u du. And then from there, we now integrate. So we're going to have u squared over 2 with our integral 0 to 1. Then we substitute where there's u, we put 1 over 2 minus 0 over 2, which is equal to 1 over 2. You see that? So we have not gone back to substitute what our u is because we changed the limits of integration. We moved from x to u completely, that there's no need of going back to x. So there are times when we would go back to x, that is, if we have left the limits the way they are, then we would have gone back to x. But since we changed the limits, we're no longer moving from 0 to root e minus 1, but we're moving from 0 to 1 because we had to evaluate the u at the limit points of the x variable. I hope that's fine. Let's go to E. So E, I think we picked E, yeah. What is E? E is the root of the x over the root of e to x minus 1. So now look at this. E to x minus 1 in the root and then the x up there. Not so clear whether we can use u substitution. If we can use, then what is going to be our u? Is this a radical integral, or maybe it's just a normal exponential integral? So many questions to answer. So to make our work easy, we let u be the whole thing in the denominator. We treat it like a radical integral. We do this, okay? And then quickly have the right squared and also square the left. So this is going to be u squared equal to e2x minus 1, okay? So that we can now differentiate, because now we need to look for dx. So we differentiate this, we get 2u, we get 2u du, okay? So we get 2u du equal to 2e2x dx, so that we can make dx a subject. It's going to be 2u du over 2e2x, like that. And then we come back here and substitute. So dx is 2u du over 2e2x. And then we are dividing everything by what? By the root of e2x minus 1, which is our u. So you see, first these 2's were canceling, and now we are seeing these u's are canceling. These. So we're ending up with du over e2x. Now see where the challenge is. We have changed the variable to u, but we still have e2x. So we come back here in this equation and make
Sir Keith, just a question. So after substituting there on the u, why haven't we included the u squared on the e to the power 2x minus 1? Isn't it supposed to be u squared?
We've taken the whole root. So that square came in after we're squaring the root. So initially we said, yeah, so we said let u be this. You see that, right? So after squaring it, that's when it lost the root. So now what we have is u squared is equal to e 2x minus 1. Now we're coming back to this to make e 2x a subject. So meaning we'll have e 2x is equal to u squared plus 1. So we want to get this and substitute where there is e 2x. So we'll have du over 1 plus u squared. And the only integral that looks like this is tan inverse of u plus c. But what is our u? Our u is the whole root of e 2x minus 1 and then plus c. You see that, right? Need to be asking questions, you guys. Okay, let's go to let's go to the last one. The one I said we should do last. Which one was that?
So can I just see the previous answer quickly?
Okay.
Thank you, sir.
Okay. So let's go to I. I is a bit nice because of its nature. You see, x to the power 5 over the cube root of 1 minus 2x power 3 dx. So we first go straight to the inside of the cube root and let u be that whole thing. Then differentiate it. So we'll get negative 6 x squared dx. Make the x a subject. So we'll have du divided by negative 6 x squared. This one. And then we go back now and write this guy and say, okay, look, we don't have the powers to start dealing with x power 5. So what we'll do is we'll write it as x power 3 multiplied by x squared dx. And the guy down is not a problem. It's the cube root of this guy. Then now we come and bring our substitution. So where there is x power 3, what we need to do, we make x power 3 the subject. So we're saying 2x power 3 is actually equal to 1 minus u. Okay, so x power 3 is equal to 1 minus u over 2. So where there's x power 3 there, we're going to have 1 minus u divided by 2. First, where there is x squared, we'll leave it as x squared. Where there is dx, we've seen that it has become du over negative 6 x squared. This whole thing, we're dividing it by what? We're dividing it by the cube root of what we have called u. So do u 1 over 3. So this is the integral for everything. So we can multiply this 2 and this 6 will give us a 1 over negative 12 outside. And then we'll have the integral of, see, this x squared and this one will cancel. So we remain with 1 minus u du over u to the power 1 over 3. Okay, so we'll have minus 1 over 12. And then we are pushing this u to the numerator. So we'll have u negative 1 over 3 minus u 1 minus 1 over 3 is going to be 2 over 3. And then du. So I was saying 1 minus 1 over 3. Yeah. Then we integrate it. So we have negative 1 over 12. Then the integral of that we are adding a 1. So we get u 2 over 3 divided by 2 over 3 minus, when we add the 1, it becomes u 5 over 3 over 5 over 3 plus c. But here we didn't have limits, so nothing was changed. So we can bring back our u. Wherever there is u, we put the right u. So we'll have minus 1 over 12. We can write this as 3 over 2 multiplied by what? Multiplied by 1 minus 2x3 to the power 2 over 3 minus 3 over 5, 1 minus 2x3 to the power 5 over 3. That plus c. I'm saying that plus c. That becomes our integral. Okay, so that was part I.
So can I see how part I was again?
It has disappeared. When it cuts itself, it disappears. So unless when it comes in the video. Okay. So we do question 2 now. I think we did A, we did B. So we'll do C, we'll do D. Which are, we can even do H. So let's start with C.
So G as well.
G. Okay. We'll do most of them then. So we're doing question 2, C. So we have cosec 4x cot 4x dx. Now, when you have the even powers of cosec and cot combination, what you do is you go to cosec and reduce the power. You break it into 2. Okay, maintain the cot like that, and then change one of the cosec using the identity 1 plus cot squared x, and then keep the other one. So we want this to be used as our du. So now we can let u to be cot x, since we know that its du is cos x squared x dx. In fact, it's negative. Okay, so we're going to write this, the integral of 1 plus u squared, and then u power 4. And then this whole thing has become du, provided we put a negative outside. This is the du because it's the cos x squared dx. And then now we can do the expansion here. Becomes u4 plus u6 du. Then get the integral. So we'll have negative u5 over 5 minus u7 over 7 plus c. Meaning, what is our u? Our u is cot over 5 minus cot over 7 plus c. Like this. Quite easy, that one. Then D. How does D look like? Tan 4 theta minus 1 squared d theta. So the fact that it's squared, it means that we need to write it as tan 4 theta minus 1 multiplied by tan 4 theta minus 1 d theta. That's what the square means, that multiplied by itself. But again, of interest is the same tan. So let's fix one. But then the other one can be written as the difference of two squares. So it will be tan squared theta minus 1, and then tan squared theta plus 1 d theta. But what is tan squared theta plus 1? That's like, so we have tan 4 theta minus 1, and then we have tan squared theta minus 1. Then tan squared theta plus 1 is sec squared theta. So just here, we let u be tan theta. Since we know that our du is now there, sec squared theta d theta. So we can write this as u4 minus 1 multiplied by u squared minus 1, and then du. Then do the expansion. So it will be u6 minus u4 minus u squared plus 1 du. So we integrate to have u7 over 7, and then we have u5 over 5, then we have u3 over 3 plus u plus c. What was u? U is tan. So we have tan 7 theta over 7 minus tan 5 theta over 5 minus tan 3 theta over 3 plus tan theta plus C. You see that most of it is not even complicated. What else are we doing here? We do G or H.
So I think both.
Let's do G. Okay. Let's start with G. Ln 2 negative ln 2. Hyperbolic cos over hyperbolic sine plus d theta. So this one, the easiest is we conjugate down and up. So we multiply by cos theta minus sin theta. We do the same down. We do that and multiply by the same. Okay. That is going to be cos squared minus this over, when you conjugate down, we are getting cos squared minus sin squared. Like that. But this is the identity. We know that cos squared minus sin squared is equal to 1. So we're going to have just the integral of this. We're going to have that. So now at this point, we can integrate. What's the half angle formula for hyperbolic tan? So we have this, and then that we're going to use.
So How
Hello.
did we get to the cos squared theta minus cos sine d theta?
So we are multiplying this by that, this by that, this by this, and that minus, by that. So you see that some things will cancel here. Only these two will remain down here. And then this is the identity. This is this identity. This one. Then we have this identity. We have this cos 2x is equal to cos squared x plus sine squared x, which takes us to cos 2x equal to 2 cos squared x minus 1. So that if we take one the other side and divide by 2, we are going to have this guy equal to 1 plus this guy divided by 2. So that's what I'm going to bring here. We'll write 1 plus cos 2x divided by 2, and then minus cos theta, oh, this is theta, cos theta hyperbolic sine theta d theta. So when we integrate this, we'll get theta over 2 plus hyperbolic sine 2 theta over, it becomes 4 because that 2 that comes from here times the 2 down will have 4. And then minus, to integrate the product, to integrate this, we let u be one of them. Suppose it's cos theta. Then du will automatically be sin theta d theta. So then meaning that we're going to just have an integral of this kind, u du, meaning we get u squared over 2. So since our u is cos, we'll have cos squared theta over 2. And then we have limits of integration. So then we can substitute these. So we'll have ln 2 over 2 plus hyperbolic sine 2 ln 2 over 4 minus cos squared ln 2 over 2 everything minus negative ln 2 over 2 plus hyperbolic sine 2 neg ln 2 over 4 minus cos squared minus ln 2 over 2. So though we could try to simplify if we converted the hyperbolic sine and hyperbolic cos to exponentials. Or since you have done the correct substitution, you can just leave our answer there, it's fine.